In this video we start a second part of SAT12 exam, a second mathematical part, the part in which you are permitted to use calculator. And well, here we have also in the beginning some formulas that you can look in when you are writing this exam. Some geometric formulas like for an area of a figure, for a circumference of a circle, and also for a volume of 3D figures, and some special right triangle, the dependencies between sides, and here you have a Pythagorean theorem. So you can use this. Well, that's much less than the book of formulas that you can get on Polish material, which is basically a 30 pages book with different formulas and theorems. But, well, here it's something like this. Okay, so exercise 1. So, John runs at different speeds as part of his training program. The program shows his target heart rate at different times during his workout. On which interval is the target heart rate strictly increasing, then strictly decreasing? Okay, so it's basically a question when the function is increasing and then decreasing strictly, so no constant. Okay, so answer A, between 0 and 30 minutes. Well, we can see that in first 10 minutes it's increasing, but then it's constant, so it's not the right answer. In B, between 40 and 60. Well, between 40 and 50 it's increasing, and then between 50 and 60 is decreasing. So yes, that's the correct answer, although let's check also other answers. C, between 50 and 65 minutes. No, because between 50 and 60 it's decreasing, and then between 60 and 65, I guess, it's increasing. It's the other way around. We would like first increasing, then decreasing. And here it's first decreasing and then increasing, so it's not a right answer. And D, between 70 and 90 minutes. 70 and 90, very not right answer, because it's first it's constant, then it's increasing, and then it's once again constant. So no, it's not strictly increasing then strictly decreasing. So for question 1 we have answer B. Okay, so now exercise 2. Let's check. If y equals k times x, where k is a constant and y equals 24 when x equals 6, what is the value of y when x equals 5? Okay, so we can write an equation here. We can substitute 24 for y and x for 6, and we will get equation 24 equals k times 6. And now we can divide both sides by 6, and we get 4 equals k. So k is 4, so our formula is y equals 4x. So now what is the value of y when x equals 5? Well, let's just substitute 5 for x, and we get y equals 4 times 5, which is 20. So that's answer C in question 2. Okay, and exercise 3. What we have here. In the figure above, lines L and M are parallel, and lines S and T are parallel. If the measure of angle 1 is 35 degrees, what is the measure of angle 2? Okay, maybe I will write this down. I will draw it. So here we have one line. This is M. This is L. Here M. Here is ST, and we want here is S, and we want T to be parallel. So I will copy, and paste. And this way we get them parallel. So it is S and it is T. And here we have 35 degrees. Well, calling an angle just 1 is not typical in Poland. We would rather call it alpha or beta. Let's call it here alpha. And we want to calculate alpha. Okay, so here it's 35 degrees. So this angle here is the same as 35 degrees. They are vertex angles or something like this. I'm not sure how is it called in English. Okay, and here, if line S and line T are parallel and line L and M also, then this figure here is parallelogram. That's how it's called. At least that's what Google Translate tells me. If that's the case, then we can calculate all its angles. For example, this angle here on the other side of this parallelogram is the same as here, so it's 35 degrees. And those, if we add this one, this beta, and 35, we will get 180 because the angles that lie on the same side of parallelogram always give in sum 180 degrees. So we could calculate that this is 145 degrees. And well, alpha and 35 and this 35 degrees also give always 180 degrees. So alpha is also 145 degrees. So it's answer D. And a funny thing, if I would look at the answer, I would know it without calculating because one is this angle one is 35 degrees, so it's an acute angle. It's an angle that has less than 90 degrees. So this drawing is pretty okay. It shows acute angles as really acute. So when you look at 2, well, it's obtuse angle. So an angle that has more than 90 degrees. So the only answer that fits this is D, 145. How can you have 70 or even less degrees here? So yeah, it's pretty obvious answer here. Thank you for watching my videos. If you like it, please subscribe and turn the notification bell and do all this stuff that happy viewer does after watching a video. And well, have a good day.